Greetings, complex numbers, part B. Complex numbers multiplication. Example, multiply these two complex numbers, 5 plus 2i and 5 minus 2i. Now we will write them down, 5 plus 2i and 5 minus 2i. We will use the FOIL, F for first with the first, 5 and the 5, O outer with the outer, the 5 and the 2i is stored in the outer side, and inner times inner, 2 and the 5 here, and last with the last, 2i and negative 2i. Now let's perform it, 5 and 5, the first and the first. We'll have 5 multiply 5, so it will be equal to 25. Okay, now it's time for the outer with the outer, 5 and negative 2i. So 5 multiply negative 2i will be negative 10i. Okay, now it's time with the inner is the inner, the 2i and the 5i. 2i multiply 5i will be positive 10i. Now finally it's time with the last, positive 2i and the negative 2i. Multiply each other will give us negative 4i squared. Now these two, negative 10i and positive 10i, will cancel out each other because they have the same sign, and we will break this negative 4i squared to be 25 minus 4 multiply negative 1, as I squared is always equal to negative 1. Okay, so the negative will cancel out the negative. It will be 25 plus 4 equal to 29. Okay. Let's see an easier solution. Since 5 plus 2i and 5 minus 2i are two conjugate numbers, so we can use the difference between two squared formula. A squared minus b squared will be equal to a plus b and a minus b. Here we have something like that as a plus bi and a minus bi. You can apply that to here too. Let's see an example. Have 5 plus 2i and 5 minus 2i. We'll take 5 squared and the 2i all squared. Difference between two squared. This is the a, the 5 is the a, and the 2i is the b. And we squared them both. Okay, it will be 25 minus 4, the 2 squared is 4, and I squared is negative 1. It will give us the same result. The negative will cancel out the negative, and we'll have 29. Exercise 1. Find the conjugate of 3 minus 4i, then multiply them. Okay, we have 3 minus 4i here. We will reverse this sign. So it will be 3 plus 4i. This is the conjugate of 3 minus 4i, and also 3 plus 4i has a conjugate also of 3 minus 4i. Okay, we will multiply them together. Can use the difference between two squared formula, so we can have 3 squared minus 4i all squared. So it will give us 9 minus 16 multiplied negative 1. The negative will cancel the negative here. It will be 25. Multiply 2 plus 8i and 5 minus i. Okay, these two complex numbers are not conjugates, so we can't use the difference between two squared formula. So we need to factorize it. We need to solve it by using FOIL method, not factorize it. Okay, so we have 2 plus 8i and 5 minus i. With the FOIL, here the first and the first, 2 and 5, 2 multiply 5 will give us 10. Then outer with the outer, the 2 and the negative I here, 2 multiply negative I, negative 2i, and inner with the inner, the 8i and the 5 will give us 40i, and finally last with the last, the 8i and the negative I will be negative 8i squared. So we'll gather these two, negative 2i plus 40i to give us 38i, because the two are imaginary. Then we can break this I squared to be negative 1, negative 8 minus 1 to be positive 9, positive 8, I'm sorry. So it will be positive 18 plus 3i. Okay. We can use the calculator to help us solve this question. It's very easy here. We'll use mode and 2 for complex. We will use shift, then 2, and use 2 to get the conjugate here, and type 3 minus 4i. It will give you its conjugate. Okay, now we will multiply it to 3 minus 4i. Here this is the conjugate of it. It will give you 3 plus 4i. It will give you 25. Don't need to write 3 plus 4i because it's already calculated the conjugate for you. Okay, now we will calculate 2 plus 8i, close the bracket, plus multiply 5 minus I. Don't forget I is ANG, equal 18 plus 38i. See? Okay. Divide these two complex numbers. This complex number division here. You are done with the multiplication. Okay, we'll divide 2 plus I and negative I. Okay, we have 2 plus I over negative I. To get this equation in the standard form, we need to remove this I downstairs. So we'll multiply them by I up and down. So it will be 2 plus I all multiplied I over negative I squared. Okay, it will be 2I plus I squared over negative I squared. Okay, let's break this I squared down there. It will be negative 1, because I squared will be negative 1. Okay, so it will be 1. So we have 2I minus 1 over 1. But I put negative 1 plus 2I, not 2I minus 1. Put it in the standard form, because you put the real first, then the imaginary. Okay, this is the standard form. Okay, example, divide these two complex numbers, 1 minus li and square root of negative 5. You will say square root of negative 5 is not a complex number. I tell you no. Take a closer look. Here it's negative 5, negative root 5. Sorry, square root of negative 5. It's equal to square root of 5 multiplied square root of negative 1. And the square root of negative 1 is I. So this is a complex number, root 5i. Okay, we have I minus 1 over root 5i. Let's take rid of both the imaginary number down there, the I, and the square root of 5. So we'll multiply them by root 5i, up and down. So we'll have root 5 and root 5 will be, root 5 squared will be equal to 5, and I will give us I squared, and we have 2 plus I root 5i. We will have negative 5 down there, and 2 root 5 minus root 5. We'll divide them. The negative root 5 over negative 5 will be positive root 5 over 5. We put the real first. Then 2 square root 5i divided. Negative 5 will be negative square root 2 5 over 5. Okay. Divide these two complex numbers, 1 and 3 minus I. We have 1 over 3 minus I. In this case, we can't multiply it by I. It will not solve the problem. There will still be a complex number down there. So the best solution is to use the conjugate, because it will give us a real number. So we use the conjugate of the denominator, which is 3 minus I. Multiply the conjugate up and down. So 3 plus I down and 3 plus I up. Apply it there. It will give us 3 plus I and 3 squared minus I squared. It will give you 9 minus negative 1. 3i over 9 minus negative 1, which the negative will cancel out the negative. We will have 3 plus I over 10. which will give you 3 over 10 plus I over 10, which is 0.3 plus 0.1 I. Okay, done. Divide these two complex numbers, 1 plus I and 1 minus I. Okay, we have 1 plus I here, 1 minus I. We'll multiply them both by the conjugate of the denominator, which is 1 plus I. Have 1 plus I up and 1 plus I down. Give you 1 squared minus I squared, and 1 plus I and 1 plus I. We'll use the 5 to break the brackets. We have 1 plus I, and the first with the first, and the inner with the inner, I with 1, and the outer with the outer, 1 and I. We have 1 plus I plus I plus I squared, and 1 squared minus I squared. Okay, it will be 1 plus 1, as negative I squared will be positive 1, as I squared will be negative 1, negatives will cancel each other. So we have 1 and 2i and negative 1, and we'll cancel with negative 1. So we have 2i over 2, and the 2 will cancel out the 2, so we'll have I. Remember, you can always use the calculator to solve these problems. It's very easy with the calculator. Use mode and 2 for complex. Mode 2, not 1. 2 for complex. Now we have 1 over 3 minus I equal 3 over 10 and 1 over 10 I. Type SD to change them to decimal, 0 over 3 plus 0.1 I. Okay, let's start again. We have here decimal 1 plus I over 1 minus I give us I. Okay, see, it's easy and clear. Complex number equation. When I say equation, so we have equal sign. Two complex numbers equal to each other. Let's see here. If there is an equal sign between two complex numbers in the standard form, so we must know that the real will be equal to the real and the imaginary also will be equal to the imaginary. Let's see here. We have two complex numbers, a plus bi equal to c plus di. I have the complex number 1, a plus bi, and complex number 2, c plus di. And a is the real part, and b is imaginary part of complex number 1, and c is the real part, and d is the imaginary part of complex number 2. So, as they are equal to each other, a must be equal to c, as a is the real part of complex number 1, and c is the real part of the complex number 2. And also in the other side, the imaginary must be equal to the imaginary. B must be equal to D, as D is the imaginary side of complex number 1 and D is the imaginary side of complex number 2. Okay. Let's take an example here. Find the value of x and y which satisfies the equation 2x plus 1 plus 4yi equal 5 minus 12i. Okay, let's see the real part here. It's 2x plus 1. This is the real part. And 5 is the real part here in the other side. So let's put the equation again. 2x plus 1 plus 4yi equals 5 minus 12i. We have 2x plus 1 is the real part of equation 1 and the 5 is the real part of equation 2 because they have no I. Okay, so 2x plus 1 must be equal to 5. So let's solve for x. Send 1 to the other side. It will be 2x equal 5 minus 1. So 2x will be equal to 4. And x will be equal, send the 2 by divide to the other side, so x will be equal 4 over 2, so x will be equal to 2. Okay, let's see the imaginary part. On the other side we have 4y at the imaginary part and negative 12i at the imaginary parts of the other side, so they must be equal to each other. So 4y is equal to negative 12, so we'll send the 4 to the other side by divide. So y will be equal to negative 12 over 4. So y will be equal to negative 3. Okay. Find the value of a and b, which satisfies the equation 2 plus 2i and 1 minus I. Now, and equal a plus b. Now the equation in the right hand side is in the standard form, but on the left hand side it's not in the standard form, so we must make it in the standard form. We'll use FOIL here to simplify the equation in the left hand side. So it will be 2x plus 2i multiplied by 1 minus I. We'll use FOIL here. First with the first, 2 times 1 is 2, and outer with the outer, 2 and negative I will be negative 2i, and inner with inner, 2i and 1, positive 2i, and last with the last, 2 and negative I. It will be negative 2i squared. Multiply them, give you negative 2i squared. Okay, these two numbers will cancel out each other, negative 2 and positive 2i. So we're only left with 2 and negative 2i squared. Let's break this negative 2i squared to negative 2, multiply negative 1. It will be positive 2, the negative will cancel out the negative. So finally it will be equal to 2 plus 2, it will be equal to 4. Find the value of x and y which satisfy the equation 2 plus I multiplied by 2 minus I over 3 plus 4i equal x plus y. Also, as previous, the right hand side is in the standard form, but the left hand side is not in the standard form. So we need to put the left hand side in the standard form. But as you see here, these two brackets are conjugate. 2 plus I and 2 minus I are conjugate. So you can use difference between 2 square to simplify it easily. So it will be 2 squared minus I squared over 3 plus 4i. Okay, so 2 squared will be 4 minus I squared will be negative 1 over 3 plus 4i. To get rid of the 3 plus 4i, we need to multiply it by the conjugate up and down. Okay, it will be 5. We'll multiply 3 minus 4i and 3 minus 4i up and down. So we'll have 5 up there, 3 minus 4i over, we multiplied it by the conjugate, so it will be 3 squared minus 4i squared. Simplify it more, we have 9 minus negative 16, as I squared will be negative 1, and 5, 3 minus 4i. It will be 5 over 25. Simplified, 5 over 25 will be 1 over 5, divided 5 up and down. So I have 3 minus 4i over 5. So I have 3 over 5 minus 4 over 5i. Now it's easy and it's in the standard form. You can use this equation now. 3 over 5 minus 4 over 5 equal x plus yi. So the x will be equal to 3 over 5 and the y will be equal to negative 4 over 5. Okay. This question is a little advanced. So if you don't understand it, it's no problem. Okay. Find the value of x and y that satisfies the equation 2x minus y plus x minus 2y I equal 5 plus I. Okay, take the real part and the imaginary part. The real part here, 2x plus minus y, and the real part here is a 5. We have 2x minus y equal 5, and the imaginary part, x minus 2y, I, and 1i here. So x minus 2y equal 1. Okay, let's see here. After we get these two equations, there is two strategies to solve them. Let me show you the first strategy. It's a bit harder than the second strategy. Okay, we can multiply both sides of this equation by negative 2. But why negative 2? Okay, why multiply it by negative 2? 2, make it, we have 2x here. I want to put negative 2x to cancel the x with x to know the value of y directly. Okay, so we'll multiply this equation by x in both sides. Okay, so I have negative 2x plus 4y equal negative 2. I have negative 2x and negative 2 multiplying negative 2y will be positive 4y equal negative 2. Okay, and get this equation. and add it with this equation. Okay, equation 1 with this equation 2. With this equation here, and add them. Negative 2x with 2x cancel out each other. So we have here 4y minus 1y, it will be 3y, and negative 2 and 5 will be 3. So 3y equal 3. We have y equal 1. So we can substitute with y equal 1 with any of the two equations. So we have x equal 2y equal 1. So we have x minus 2 multiply 1 equal 1. So I have x minus 2 equal 1. Send it to the other side. So the x will be equal to 3. Okay, let's see the other way. It's a bit easier. The other way is we want to get x in terms of y or y in terms of x, then substitute in the other equation. But this will work if you have only two variables, okay? If you have 3 or 4 variables, this way might not always work. So let's see here. We have negative y, we send the 2x to the other side. We have negative 2y equal 5 minus 2x. Multiply the both sides by negative 1. We have y equal to x minus 5. Negative 2x became positive 2 and 5 became negative 5. And I switched them. So we have 2x minus 5. Okay, now we have y equal to x minus 5. Let's substitute in this equation. Put the y in this equation to be 2x minus 5. So we have x minus 2, not y here, we put 2x minus 5 equal 1. Okay, let's solve. We have x minus 4x plus 10 equal 1. Let's send the 10 to the other side, and x minus 4x will be negative 3x, and 1 minus 10 will be negative 9. So we have negative 3x equal negative 9. 10 the 3 to the other side by divide. So the x will be equal to 3, just as the previous solution. You can use the 3 to substitute in any other equation. You will get the y easily. Okay. Thanks for your time. You were born to win, but to be a winner, you must plan to win, prepare to win, and expect to win. Dig Ziegler. Thanks for your time, everyone. Goodbye.